cool.
Oh, it seems like we started.
Are we starting?
Am I on?
Yeah.
Can you guys hear me? Yeah. Hey, hi, I'm Julie. I'm a unicorn, in case you didn't notice. This idea for this panel was actually started by Anton and I a while back. Like, I knew you lived in LA, and we were like, hey, Unite LA coming up, let's do this. And then we also spoke with Kayla and also Sarah, Lucid Trips, and Chet from Valve. Unfortunately, Sarah and Chet couldn't make it. And I kind of knew already, but I still pushed it to the last moment. But then last night, I asked you guys, well, we were drunk, whether you could, well, I was drunk, I can say that, right? Whether you guys could make it on the panel as well. So here you are. Yeah, I was worried I wouldn't be able to make it because I've been sick for a long time. I'm technically here on a sick leave / holiday. I think that's what I told my doctor. But whenever I wear my unicorn costume, I feel fine.
I was preparing myself for just Anton and I being here by ourselves. Which would have been totally fine. So, hi everyone, I'm Kayla. Good to meet you. So I'll be doing the joy and awesomeness of moderating this panel since Chet couldn't make it here. What I'm going to let each of the panelists here do is introduce themselves, tell you a bit about what they're working on, and also tell a story of the weirdest glitch or bug that they've experienced in VR so far.
Cool. Testing. Oh, there we go. Hi, I'm Anton Hand from Rust Limited. Our current game on Steam is Hot Dogs, Horseshoes, and Hand Grenades for the HTC Vive.
I think they like your game.
Man, oh man.
And
probably the best glitch that I've had while working on it was working on this sort of two-handed object called a Graviton Beamer. This is sort of like the Half-Life gravity gun, but way junkier. And it had these sort of flaps on the front of it that would vibrate while it was active. And I would apply physics torque to them. And this worked great as long as I was holding it. And discovered about 10 minutes later, every time I would set it down, that was just enough physics force to have it repeatedly wipe everything off the table and then go to space. So, fantastic glitch.
Hi, I'm Graham Borland from Alchemy Labs. I'm a programmer at Alchemy. I worked on Job Simulator and now Rick and Morty Simulator for the Vive, and Job Simulator is multi-platform, so we're on touch and PSVR as well. One of the craziest bugs I've encountered working on Job Simulator stuff specifically was we get like really specific, obscure bugs with a lot of stuff because everything is like based on individual props and like sort of micro interactions. So we have a copier in the game that copies. It's like a photocopier, but it copies items. And we had this issue where you would put an item into the photocopier and it would come out and be zero gravity. It would just sort of drift out of the copier, and we couldn't figure out like why would that cause an effect? How could this possibly happen with game physics? And eventually we figured out we have all this crazy physics for your hand for like how to joint stuff into your hand when you're holding it. And part of that is actually to turn off the physics of an object that's attached to your hand so you can sort of, the gravity force isn't fighting you when you're moving an object around. And if you can grab it at the right second during the copying process, that attribute is copied onto the copied object and it's just serialized in, and then you have floating stuff. But if you get really good at timing it, you can sort of fill the air with 0G, whatever you want. It's pretty cool.
Sounds like how I work.
Yeah.
Hey, I'm Elliot Mitchell from Vermont Digital Arts. We are working on a VR game, Waggle Words, but I also do a lot of other projects. I just worked on the Bjork Digital VR experience, and I did some work on the Leviathan project that was at Vision Summit. I think the strangest VR glitch I've had might be more human error from artists trying to optimize out 3D and removing colliders. And so in the Leviathan project, you're this giant floating whale with a cyber, like a steampunk kind of lab under it. And I was doing some lighting and VFX for it, and either I accidentally deleted colliders or I'm not sure, but I was walking around doing lighting and suddenly I fell through out of a floating lab on a whale, and next thing you know, I'm just like falling on the ground, like what the hell happened? So yeah, don't over-optimize out your colliders.
We need colliders anyways. Yeah, so I'm part of VR Unicorns. We already have selfie tennis out. We also work in ski jump and archery. We're a bunch of game jammers, and especially if I get to touch any code, it goes wrong. So I don't anymore much, only if they don't see it and don't know it. But we have like a weird glitch in selfie tennis. If you guys play selfie tennis at any point, like we have these tennis ball hats, and they're all ragdolled when you kill them, which is amazing because that's what I do in the game. I don't really play tennis. I just run around on my ponycorn and slap them with the lightsaber. But whenever you do that, like when they sort of fly in really sort of high velocity, they just completely glitch out. So like their arms and legs are just flying around the level. And that's a bug. And we believe in bug turning features, so we just deliberately decided not to do anything about it. I also wanted to note, Sarah, Lucid Trips, will be here sometime later today, and hopefully Chad will make it in tomorrow. He's unfortunately sick, so, but he's getting better, so he hopes still to make it in case someone of you wants to hang out with him.
Awesome. And a bit about you guys. So who here is currently actively developing in VR right now?
Yay!
It's getting better, it's getting better. Who here has shipped a game in VR so far? All right, you see, every single time we do this, it gets better and better,
Yeah.
Awesome, awesome. So because this is a VR panel, we are legally obligated to talk about performance. I don't know if you know this, but performance is important in VR.
Puke simulations
90
all the
frames
way.
per second, it's a law. So let's just start with a few of those questions here. So for the panelists here, how late or early into the project did you start thinking about performance? Maybe we'll start with Julie on that one.
Yeah, so since we were working on a game before we started accidentally making really crazy, weird sports games, we were working on a game called Ragnarok VR, which was sort of semi-realistic graphics, pain. And performance was a huge issue, especially also because I was back then always showcasing on a Mac. I'm fucking stubborn. Until at one point nothing was supporting Mac anymore, and then also we got the Vive, and then we just shifted everything and realized that that it was way more fun to do room scale games. But yeah, performance was definitely something we thought about from the very beginning because we learned it the hard way on a Mac. So when we started doing our weird-ass sports games, we just decided that the art style would be very sort of toony, and all like the artists that we work with are all people with a background in mobile development because you need that, and especially where we're at now. We don't want to sit and worry too much about performance. We just really want things to work from the get-go because our interest is about finding the core mechanic, and then we actually build up most of the like environment and art, all assets, they come in later. So we work on getting things to work and figure out the core mechanic for steering or whatever, depending on which game it is, and then we add art. So that's how we work. And for that, we just make sure that the art style is something that's actually doable in VR, so we don't have to optimize too much and wiggle with that.
We think about optimization from the get-go. I have been working in mobile for 8 years before getting into VR. And I've been doing 3D for 25 years. And so it seems like every time I think there's technological advancements in 3D, I step into a platform that brings me back several years. And so those skill sets come forward. WaggleWare started out as actually a mobile game first. And so we'd already figured out that, and then it worked really well. The one spot I don't have a good ability to optimize is sort of like post effects and image effects. I tend to I optimize heavily on the 3D side and the art side. I have better engineers than myself review my code to make sure it's not updating all the time. And then I get to splurge on image effects and cinematic effects.
So for optimization with Job Simulator, we kind of started at the beginning with high-level design decisions that would affect performance down the road. So like the main thing being the art style. And we actually made the decision to go with like the more toony stylized art style for stylistic reasons because we thought it looked better when stuff's getting in your face and you don't see like creepy, like hyper-realistic, normal mapped hands, like getting all up in your business. It was sort of more aesthetically pleasing to go simpler, and that kind of informed like all our direction and stuff, and ended up like allowing us to not have to worry about that stuff too much, because the fact that we were doing toony stuff just meant it was going to be simpler overall. And the stuff that came later on was more like gameplay and script optimizations, which gets into crazy stuff of like, shaving off 0.1 milliseconds where you can in everything that updates, and that kind of stuff came later because you don't want to spend a huge amount of time, because it takes a huge amount of time to optimize that stuff until you know exactly what things you're going to need. Like even if we just had like one prop on a desk that's got an update loop and it takes point whatever milliseconds, we don't want to spend a day making that prop better because it's so easy to just be like, well, that prop's not going in the game because we changed something. And like we'd cut entire levels and groups of objects and stuff that aren't worth optimizing. So the design decisions early are super important for like setting the bar for like where your performance is, especially for art, I think. But that script stuff kind of has to come later once you know what's going to be in the game.
So before H3 was a game, it was actually just sort of my experimentation platform, both figuring out, doing room scale VR stuff, and in addition, we as a studio work on a shader system called Alloy, and because I was a bit late in the early adopter cycle for the Vive Pre, I'd been getting all of these warnings from folks about like, you can't do photorealistic stuff, it won't run well enough, you have to abandon all the PBR stuff you've been doing for several years, and I was recalcitrant. So all of my early experimentation was finding exactly how far up to the precipice of disaster I could take everything aesthetically, and then working back from there to see like, okay, I can have the shiny stuff in these very limited contexts if I'm super careful. So that was that was part of probably the first month and a half of my focus, was trying to be able to keep my shiny toys.
I have one thing to add, like, so for us, like, when doing single-player games, like, we're like, okay, we got this, because then we only had to worry about art and not so much optimize all the code and whatnot. Like, we have rewritten a lot of the code in all games several times. But then we decided the ski jump should be multiplayer. And we realized, we were like, shoot, do we know how to do this? Of course, like, I'm the idea guy around here, so I'm like, I want multiplayer. And then I'm like, I don't know how to do it. So we actually teamed up with my brother's companies, Apex Game Tools, because they know how to write super clean code from the get-go. And I would say, like, so now it's a way more sort of programming focused than it was before. Like, before it was mainly one coder that we all stared at, Horatio, all the time, and being like, I want this. And he would like, sit like a coon monkey, go crazy. Luckily, he's a young kid, so he can do that very fast. I'm not so young anymore. But we realized how much we need to optimize for multiplayer, because like no latency, whatever, like compared to what before we could get away with a lot of jammy code in self-attendance, trust me. And it's all bug turned feature. Like, we're not gonna fix that. It's like, oh, there's a bug, yeah, let's pretend it's a feature. We got this.
So Anton, you brought up a really good point there of how you kind of try to find that edge of how far you could go with things, and then you were kind of exploring that area. There's been a lot of investment over the last year in making engines faster and getting better at VR stuff. Have you been able to take advantage of that and go back to your work and take that bar even further, or?
Well, I'm a bit of an odd case, because I've had this repeated, I would love to upgrade the version of Unity I'm on, and I keep running into that one corner case that ends up preventing me. So I'm still stuck on 5.3.3 at the moment with maybe the first version of the Steam VR plugin that postdates the Vive release with a bunch of things messily changed all over the place. So it's a bit of a mess.
Well, try to just update on another computer and another build or something.
I'm
the one doing the
I
new
keep
update
trying.
tests.
It's crashed to desktop every time.
I'm always the one being like, let's go on the new one, and then I test it, and the other ones are like, no.
Okay. Anybody else on the panel has a?
Are you still on 5.3 as well? We're on 5.4.
No, I'm like a beta addict.
Yeah, me too.
Whenever a beta comes out, or like the cinematic effects, like they're not fully supported in VR, but I try them anyway. I'm like a VFX
living on the
addict,
edge.
but using good version control is kind of key to that. I also find, maybe this is what's happening to Anton, is sometimes internal things in Unity, like the UI system or like the Steam or like prefabs in general, break when you update, and you just have to destroy them and make new ones, even if all the settings are the same. So that's bad stuff does happen when you live on the edge like that.
Yeah, we do both. Like, we're on 5.4, but yeah, like always having someone basically like, hey, new version of Unity came out, like let's just see if this will work like at all with what we're doing, and just sort of always having someone like at least trying to upgrade it and see if we can take advantage of it, because it's always nice to move up if you can, but yeah, sometimes it's just not possible.
Or we have like one thing that I know is fixed in 5.5, and that the reason why I really wanted 5.5 is something with distances from like start position and like ski jump. Some of the levels are like 5,000 meters long. And we had some flickering in the end, and I know it's solved in 5.5, but the other guys won't let me like move to 5.5, so it means I still need to keep the levels short.
Yeah.
which is a little bit sad until I bring on them and get them to update.
Cool. So often when we talk about performance improvements on VR, we're often saying the words like draw calls and getting that stuff all optimized. But the reality is that VR optimization challenges do go far beyond that. So to the panelists here, what has been your biggest performance cost surprise in VR so far? Let's start with Anton here.
Well, just a small one. The one that surprised me literally like 2 hours before I was supposed to do a release where I was changing stuff I probably shouldn't have been, was a reflection probe lookup, which is one of those costs that you don't even think about because we typically think about that in terms of shading cost. But I had made a level that was probably a little. There were 86 reflection probes in this level, and it wasn't even a very big level, but I wanted them perfect and 100% coverage, all box projected. And then I hit play on it, and the view wouldn't even come up in the headset. And I was like, what's going on here? And so that scales linearly as a cost per renderer. And because I had hundreds of those, all with blended reflection probes, I very quickly, I couldn't hit a single frame in time, so I just had to turn those off. So it was enough. With about 100 of them in a scene, the CPU cost exceeds the cost of drawing the object just for that reflection probe lookup. So don't abuse those.
I feel bad probing you to reflect on that.
One thing that we ran into that was a big issue, if any of you were at Devin and Alex's talk just now about optimizing JobSim for PSVR, they talked about Canvas, Unity's UI Canvas system. If you move one of those canvases, there's a lot of like recalculation of bounds and like just rebuilding like cached stuff every time canvas is moved. So we battled with that for a long time and came up with a solution to basically have a canvas that didn't move rendered to a render texture, which was then applied to the moving object, which comes out like way more, it sounds like more steps, but it comes out to like a way more performant result because you're not paying for the canvas moving. But it was one of those arcane things that like wouldn't really show up well in the profiler. Like the cost in time associated with the canvas would not necessarily be attached to the canvas in the profiler. It would show up as like just miscellaneous camera, something changed 4 milliseconds, and you're like, well, I need to know what that is. Yeah, and in a similar vein, moving transforms with like complex hierarchies has a similar type of cost where transform like bounds and stuff have to be rebuilt, and we ran into that a lot where we had to just optimize like our hierarchies and simplify like how many transforms stuff had, because there wasn't really a way around that. Like it's just a problem in Unity that thankfully they're kind of addressing more now. But yeah, going into deep profiler and like trying to find out where those issues are actually coming from was super important, but there's a lot of like weird costs that are sort of hard to address.
And also just using the profiler sometimes messes everything up as well. So it's like, what am I dealing with here?
So I was going to mention canvases, but I won't. Wagglewords has maybe 200 canvases in it, and they're all hooked to physics objects.
Yay.
And so, he's looking at me in horror.
Pain.
The game still runs at 90 hertz, all right? So I think that the biggest surprise for me actually has to do more with UVs. And I don't know how many of you are familiar with what UVs are? Almost nobody. UVs are when you have a 3D model and you unfold it into 2D space. Each UV corresponds to a point on the 3D mesh, a vertex. And so you use UVs to texture, but you also use UVs for light mapping, and we'll probably get into light mapping more later. And a GPU can only support one, like if you have like a hard normal angle, or if you have a seam in UVs, like how your texture, it splits the vertex into multiple vertices. And so the amount of performance hit you take when you just take an asset, a 3D asset from your artist, and you put it into the Unity editor and you just click like auto unwrap UVs, you can go from, if you had an artist unwrap your UVs, you could have maybe, I'm just saying like a number like 1,000. You can auto unwrap and have 30,000. And then if you're using the real-time GI and then baking light maps and all this other stuff, it makes 3 different there's 3 different maps you're using. And so your vertex count goes up, and it can really tax the GPU. And when you're doing mobile VR development especially, it just kills you. So yeah, unwrap your own UVs. You'll be surprised how much performance you get out of it by doing that.
We had like a very different case. We have a selfie stick in selfie tennis, and you can tweet out a GIF that you record on the selfie stick, and whenever like that moment we were tweeting it out, because we went through Twitter's API, like then we had a performance hit. And we probably spent like the 2 last days before launching, we spent on trying to fix that. And it was just like, and again, it's just like a gimmick in the game, but we were so obsessed with it. I think I was so obsessed with it. So I just forced the guys, and we were working on this, sorry.
Would it just hang the app?
Yeah, it would just like, it would just hang. Like, and it was enough for me to notice, and I just didn't like it. So I guess I pretty much forced it through. Horatio, again, was sitting up all night working on trying to fix it. And we had Ralph from Unity on call, who was in Denmark. We were in San Francisco, and we had him on call, like helping us fixing it, because we were like, we cannot ship with this performance hit. We don't want it. Selfie is a very sort of light game, performance-wise, but this one like was a bit of a bitch, to be honest, to deal with. So we fixed it eventually.
Cool.
By the way, Kayla is mainly here just to make sure that I don't.
Yeah, the big thing is she has threatened to drink while on stage, and
I'm
so
awfully sober
if you see
right
her
now.
sneaking like a Mickey behind my back, flag me. Okay, so that was performance. Let's get into physics and interaction type stuff. So physics systems as they exist in our game engines today really weren't built with VR in mind, and we're kind of just discovering how they work now that we have full 6DoF interaction capabilities. So maybe we can just talk about how physics is working in your project or not working in your project, some of the problems that you're facing, and maybe some of the ways that you're kind of working around them right now. Let's go on that way and come back this way.
This was how it all started. It was Anton and I bitching about physics. We were like, let's talk about this one day. Yeah, let's do it. United LA, we're doing this. Yeah, we had like a few obstacles with physics, with especially regards to self-tennis, like fast-moving objects, and we ended up having to. Also, we didn't know anything about tennis when we made the game, so it was also one of the complications. So we knew nothing about tennis, and we like knew something about physics. But when we had people playing it, and they would tell us it didn't feel real, and we were like, "You just don't know how to play virtual tennis." And then, like again, effort on Horatio. At one point, I think I finally convinced him that we need to do like something that at least feels like semi-realistic physics. And we had tennis coaches coming to our office in Copenhagen and working on that. And he probably crunched for a month on trying to make write his own physics system for that. We still use the collision, like Unity's own collision, which means that in 5% of all cases, the ball actually goes through the racket. And we have quite a few players complaining about that. But then I'm like, you can just go out and spank people with it. Keep it a little bit, because it is like it's quite an effort to also rewrite that, especially when we also have other games in development. But yeah, physics, it works some cases, some situations, like especially we were talking about earlier in the matrices, like sometimes you just don't know what's going on. Like I checked the box, but it clearly doesn't work, and then you just uncheck everything and decide to just go with it.
Physics is kind of tough for waggle words, and back up, there's this giant beehive honeycomb that you're inside, and it's about as far as the wall back there, and it has all kinds of undulation and stuff happening in interactions, and I just wound up sort of giving up. It wasn't working that well, and I wound up going onto the asset store and buying circular gravity force, and they had some things that were controlled just enough to get me going so I can keep developing the game, and that helped a lot. And then we've been going back in and tweaking physics ourselves, and we actually started, and Anton's going to scream again, putting physics on UI assets. So there's, when you get a word and a little point comes up, the points and it floats up, and it was all using like some sort of programmatic tweening, but then the board undulates and goes through the UI, and it's redrawing as it's going up, and then we're just like, well, that's weird that the physics is causing objects to go through it. Let's put colliders on this. Yeah, actually, we're still 90 hertz, but we have programmatic tweening going on to Unity Canvas, and then we have physics from the board that's controlled by circular gravity force for the most part, and then hitting a rigid body that's constrained, and it actually works, and it probably shouldn't, but That's my experience with physics most, is either I can't make it work or I buy something at asset store and then try to fix it or hire someone to help fix it. That's why I'm friends with these people.
We had a lot of experience going in the other direction of like removing physics from things that you think would have physics. Like Job Simulator is a game that's very much just about like your hands and grabbing stuff and moving stuff and just like directly manipulating rigid bodies. And ever since like we jammed out a prototype for it, it was really clear that like just relying on Unity physics to like throw objects and have stuff bump into each other and like try to push something through a desk and have it vibrate, like that stuff requires a lot of manual work that's just math. Like in Job Simulator, when you pick up an object, your hand disappears and you're now just directly controlling the object. But that leads to a lot of side effects of like, you can't ask the hand rigid body for a lot of information anymore. So like, if you want to get the velocity of your invisible hand, you need to keep track of that yourself. Physics isn't doing it accurately for you anymore. And there's a lot of like edge cases of just wanting to get information about how your hand is moving, but your hand is bound by so many weird, like not real rules of physics that you just have to do the math yourself. And a lot of like pulling out a drawer or like moving a hinge and stuff, things that are very constrained, you can do with like a configurable joint and like go through the pain of like trying to figure out exactly how to make this joint do what you want it to. But in some cases, for us especially, like we just need an object to be able to go from here to here, and we know how to just trigonometry that out and figure it out, and we just would do that. And in some cases, literally not even use rigid bodies for stuff like that, because it was just more reliable to do the math.
We've all been waiting for your comment now.
Well, I mean, to start out with something that's actually small, one of the biggest things I run into, and it's one of the reasons why gravity in H3 is not 100% of real, it's like about 0.65, is that dealing with small objects is incredibly difficult because all of the sort of physics engines have their sort of step times and performance windows optimized around moving man size and car size objects. And the moment that you start representing things more photorealistically, you find that lots and lots of objects are incredibly thin. And in the case of H3, I would, at 100% gravity, bullets and bullet casings fall through everything, whether it's a primitive collider or a mesh collider. And so the very simple, it works well enough and I kept it sort of solution was actually just to lower gravity so that falling objects just never reach a velocity too great that happens frequently. But beyond that, probably the biggest problem that I've run into is the fact that there's no cheap way to move a child collider within a compound. So a simple example of this is if you have a handgun and have a slide on it that needs independent collision from the body of it so that you can say only chamber around at certain moments, or you actually want, if it's back, it's even just colliding with a table correctly, that is always incurring a pretty significant immediate cost when you move that set of things on the CPU. And it's almost imperceptible if you're only doing it with like one thing at a time. But it can very quickly, it can all of a sudden become a huge issue if those objects are, say, intersecting a trigger that's also intersecting half of your level. It almost destroyed H3 in one very horrible week.
I remember that 1 week.
Oh,
You were a happy camper.
Oh, yeah, just full of joy. But in a big way, so much of the engine, like there's a tremendous amount of infrastructure in H3 that's about finding clever ways to not move things except via rigid body dot position, which is suboptimal because it will never be 100% locked with your frame rate. So it's with H3, it was a compromise of just eating a really high performance cost for the things in your hands because they're really important, and for things like that are being carried on your chest, just accepting the fact that they're always jittering a little bit while you're moving to make it cheap enough.
So how much do you think like the current kind of state of physics in the engine are influencing the overall design of games? So, like Job Simulator is a kind of a silly kind of a game. So if there's little physics glitches here and there, or things don't really physics correctly, it kind of makes sense in the universe. But like, the game you're trying to work on here is trying to be a lot more realistic. I mean, it's kind of a silly wrapper around it, but I think if you had your way, it would be much more realistic kind of sim. How much like are we kind of working around these problems right now?
I think in Job Simulator, like you're right that like sort of more cartoony interactions give us more affordance to like not, if things are just slightly off, it reads as like slapstick basically. But we run into a lot of things of like just player expectations need to be met. Right. And if they're in this world that is cartoony and like stuff sort of bouncing around and glass breaks when you smash it, like if the smash velocity threshold on your glass isn't quite right, or like you twisted your hand and the glass doesn't break when you thought it would, like we have to fix that. And it's like you decide like how much are you going to lean into those quirks, and if you want to embrace them, like you have to make design decisions about like some of your objects. Of we almost have to make them like intentionally worse to fit some other things. And it's kind of like the same idea as like choosing an art direction that works is choosing a physics direction, I guess, that works, and sticking to it and making sure it's consistent.
And I think also if you're in the case of H3, where some of the things that are being asked of the player, but right up against the physics engine barely working. So an example is like inserting a magazine into a handgun magazine well. Those are all, like, we're talking about inserting something that's about 1 centimeter wide in between two things that are like 1/2 centimeter or smaller, which is right at the fidelity edge of the physics engine, which means that even a user performing that action is not necessarily going to get consistent results. If they're moving both of their hands at the same time while performing that action, it's going to be different than if one hand is perfectly still. And so I still choose to always be trying to make those work, but especially if you're going to have interactions like that can be very frustrating for folks who aren't in the like the realism is more important than it being reliable. Always have a fallback. So in the case of H3, there's a mode you can just, I want the magazines to just clip through all the firearms because I don't want to deal with physics glitches. Providing a fallback like that for users if you're doing something that's right on the edge of the system's capability is really important.
We definitely have some challenges, especially in a game like Ski Jump, where it's like fast-paced and you're moving, like it's locomotion, you're in skis, right? You use the ski sticks. Like whenever there's something messing up there, it's just unpleasant, and that was we're working really hard to solve, and kind of got there now. So that's really nice. But we had to live like flying ski sticks sometimes. It's like, just like after 5,000 meters, and your ski sticks are like 10 centimeters away because it's float-based. Oh, great, surprise! We didn't know that, but now we do.
In Waggle Words, it's I said before, it's also in parallel development in iOS for iPad. And it sounds kind of strange that there's like an iPad game that's also on HTC Vive, but it works.
Makes perfect sense.
But we actually have to tweak the physics a lot for the VR because it actually is more performant on the iPad. It's only rendering it once, and so we have to add more mass and more drag to slow it down, so there's not so the collisions will happen. Because when things are moving too quickly, it goes through. I don't even know half the reasons why, but like just even on the plane to Unite, I had to write some scripts that if it's the platform's Vive, or just PC platform, but we're primarily doing Vive, that we have to add more mass to the objects, and we have to add more resistance to them to slow them down, so that it actually doesn't just penetrate through. But on the iPad, it seems to work all the time.
Also, just something that I've absolutely adopted as a philosophy, avoid collision and trigger callbacks as much as you possibly can. It's so painful to have to hear this, but especially if you're doing very, very simple checks like hand to things, consider writing your own registration and deregistration for distance checks, just because there will be less colliders in your scene. Because, and this sort of branches out to something I've talked about a lot with with new VR developers. There are a lot of folks who are going to be using some of the sort of open toolkits that are out there, like what is it, VRTK and things like that. They're great starting points, but be aware of the fact that some of the modalities that are present in those will not necessarily scale if you are trying to do something that is 10 or 20 or 50 times more complex than any of the demo scenes that come with those toolkits. So it really behooves you to understand their architecture, because if you try to go big off of one of them, you're likely going to have to change something about the way they function to hit frame
There's
rate.
a lot of
It's a little bit,
in there.
yeah, it's a little bit like peeing in the pants. Kind of like it helps you out a little bit, but then like you realize, right, see, that's why Kayla's here. I'm not allowed to say those things on stage. I'm not allowed to get drunk. And what else was it?
Thankfully, we're running out of time.
But it is, that's the problem. Like it gets you so far and it gets the understanding, but yeah, write your own.
Cool. I do want to get into some audience questions as opposed to letting Julie continue down this path of despair and destruction. So I'm going to ask one more question of the panelists here, and then we're going to kind of open it up to see if we have anything from the audience. I mean, the reality is that as we're doing VR development, we're figuring out new ways of doing things. We're trying to stress our systems to the limit. We're using engines that really weren't built from the ground up for VR. They're kind of being now jerry-rigged to work in this new space, and they're obviously getting way better as time goes on. But if you're just kind of have one takeaway to give everyone as they go away from this, what is the biggest piece of your tech stack, your engine that's letting you down today, and maybe what is that, and how is that affecting you in terms of your design?
You go first. I have to
That's
think.
an easy one. Lighting in general, light mapping. Especially if you're doing mobile VR, you can't real-time shadows in I'm working on a project now that is also an archaeological mobile VR app, an AR app called Morgantina VR with Archimedes Digital, and we find that the real-time lighting is not good enough because you go onto site with like a Tango or something like that, and the buildings show up where the actual ruins are, but the lighting's terrible and it's all janky and it doesn't work. And then when we have a cardboard version, a Gear VR version, and a Vive version, and we can't bake light maps to a high enough fidelity to actually notice that there's like ambient occlusion happening. It just looks disjointed, and what happens with us is that you want to use light maps to save like on shadows and all that rendering stuff, but the textile resolution is so low it just kind of looks like a cartoon in this sort of realistic space. And at this point, maybe there's promise because of the new progressive light mapping stuff. I'm really excited about that. But currently in Unity 5.4, we run into a block where we can only render at 15 textiles, and it kind of looks cartoony. And it's a constant battle, and you can like let the light maps bake for 5 hours and then realize that there's all these crazy artifacts that happen and stuff like this. So.
Yeah, but I think as a part of that is solved in 5.5, as far as I
yeah,
remember.
so
Because I was geeking through all of that without issues.
There's stuff coming down the pipeline, and that's what keeps me going.
One thing I'm really excited about is the new job system, because like another game that I want to make one day that I've been wanting to make for some years, but then like graphics fidelity is one not, and it has a lot of simulations in it. The new job system seems to be like the answer to my prayers on that one. So because simulating so many objects at the same time is still kind of tricky in the current version of Unity, whereas I guess in a few versions then we get it.
Yeah, I think for me, it's a combination of two. Physics, for sure, is something that just like, we've been talking about it a lot already, but like it's one of those things that has just worked up till now because video games didn't need as intense physics as we need now to run at 90 FPS and do more complicated things. So seeing some kind of like, I don't even know what that would look like, of like a next-gen physics system that is actually designed to work for a VR would be really cool to see. But also for me, it's editor stuff. Like some of the stuff we saw at the keynote looks really interesting, of like just basic stuff of like being able to just move an object or do things like not at runtime that can actually like, you can go check out your scene. And one thing that like still happens to me every day is just the problem of like, okay, I have to go test something, so I have a bug where I grab this object, so I need to go grab the object and then take off the headset and run to my computer and hit pause.
And you get the Vive face.
Yeah,
like we have it sitting here.
Yep, Neanderthal forehead thing. But yeah, just like having more smooth transitions in and out of VR and being able to do more stuff in the headset is going to help productivity a lot, I think.
Cool, and just a fairly short one. Why the hell are physics and draw layers still the same thing? Like in H3, and I think in job simulator, like we have to use them all for physics.
Every single one.
We have none left over for draw, so we're like, well, I guess we're just stuck drawing everything. so yeah.
Yeah,
That.
request. Let's write it down, send it.
Awesome. Well, let's do a quick thank you to all the panelists here, and then we'll, yeah.
How many mics do we have? We only have
And
two.
yeah, we have limited amount of mics, but we can kind of try to pass this one around as people have questions. Oh, great. Thank you very much.
If you have questions, maybe you want to come closer if you have questions,
Yeah.
so Andy doesn't have to run.
Do you have a hand over there?
Going.
Yeah,
Over here.
yeah, let's do it over here.
Quite unlike that one.
Make it easy for you. Wow, fantastic panel. You guys are all absolutely rock stars. The kind of stuff you have put out in VR, Anton, dude, you're a geek, man. You literally, the physics in H3 is, and all of these, like, right, all of your titles, once people can play them in VR, they experience the interaction, they could sort of figure out how you did it. And you guys did it amazingly, all of you. Talk about maybe some of the things that you thought like were really cool that you did specifically in your games. Like I know the job simulator, sometimes like if you reach for something, objects will kind of move closer to the hand. All these like little tweaks that help the actual VR interaction, which you guys have done magically. So maybe you guys talk a little bit about that.
Yeah, we had a lot of like nuanced stuff with the hand, where when you grab an object, it becomes connected to your hand by a configurable joint. But obviously, it's not that simple. Like there's a lot of properties that are sort of dynamically changed, like depending on the situation you're in. So we opted for the route where if you grab an object and you try to push it through a surface, like your hand can move through the surface because it's your hand, but we opted that the object can't, so it's still bound to your hand and it'll resist, but it won't just like pop out of your hand and it won't just stay there. It'll sort of like press against the table, and you know, if you can drag it to the edge, you can get it around and stuff like that. But yeah, we had to do all kinds of crazy stuff, like even just getting that configurable joint to reliably let you do this. Like you have to, you know, change values for like drag and spring force and stuff like that depending on the hand's velocity and like depending on the mass of the object or where you grabbed it. Like long skinny objects will start screwing up if you grab it too far from the center of gravity, and just yeah, there's a lot of edge cases with that stuff for sure.
We added something we called the, oh, where did you go? There you are. We added something called the wobbliness. So it seems a little bit more like a natural joint. But that was also, we also used a configurable joint. But so we had this wobbly script, so it seemed more natural, so it wasn't too static, because that was what we experienced in a lot of other games, like back then, this is almost a year ago, right? That it was very sort of static in a way when you had movement, so we wanted something that felt a little bit more like an actual body movement.
I think it's really important to have multi-sensory input and correlations. And so in Waggle, when it's a word game, so the more letters you get, we have a tone change for each letter. In audio, a light change, like lights coming out, and then haptic feedback changing for each one. And so it's really important, like you're feeling it, you're seeing it, and you're hearing it. And then there's the physics actually changes the intensity of what's happening. And so those sort of escalating of all the senses is kind of a cool thing.
It's a really simple one, but it's if I had to put on like surprise favorite thing that I've put in was based on a user suggestion actually. In H3 there are some panels that have options. You can spawn ammunition that you can lock by just tapping a little lock icon in the corner. And what happened is that a bunch of players started using them as a table anywhere they wanted it. And so someone made the, you know, in retrospect, obvious suggestion, hey, can we just have a table we can put anywhere? And so I was like, yes. And 30 minutes later, pushed a build with a movable table, and then someone made a house out of them.
Awesome. Thank you. Thank you. We got another question right there. It looks like we're actually forming a line right there, so that would probably work out the best if there's kind of a line behind the mic. So go ahead, sorry.
Yeah, I wanted to know what you guys have been thinking about from design, like decisions with input device fragmentation, which is only getting worse currently, and I know a lot of you guys are very Vive-centric, but I'm sure you've thought about, because Touch is coming out in December, and there's just similar enough that you probably feel like it should work the same, but you know it's not going to. And so how is that affecting your design decisions for like future projects and then for ports?
So I have to share a pet peeve, because making a firearm game, you would think I'd be like, oh, custom gun controllers. And I keep seeing people doing these where they're like, oh, okay, we're going to make a custom tracked gun controller, and it has 3 buttons. That's it. Nothing else. And it's like, this is my plea to people making custom controllers. Please replicate, even if it needs to be across both hands, replicate at least 1 tracked controller's worth of input, or no one's going to be able to use your controller. Because, I don't want to speak for them, but I always feel very button constrained in I have just enough individual inputs. And so removing half or 3/4 of them is just unacceptable.
So the reason I love the Vive controller so much is that I'm a game jammer from Copenhagen community. So Nordic Game Jam, we had Move controllers very early on back then because Johann Sebastian Joust was developed there. So we all had a lot of Move controllers, we could play it. And when I first got to have and that was the first Vive controller in my hand, I was very happy with it because you had the trigger, you had the touchpad, and that was kind of in many ways what I needed because I was already doing things for the Sony Move controller. So I really like that. But it's also, we're making very physical games, very boom scale, very physical, you're smushing around. And so for the Vive controllers, it feels like a tennis racket, at least to me, like ski sticks and bow and arrow and archery. So I like them big. It's gonna sound so wrong. But for me, the touch controller still feels a little bit fragile. So I still have a hard time being very physical with the touch controllers because it feels like I'm gonna break them. Probably shouldn't say that, we do also have Oculus. But I really like the Vive controllers, but it's probably also because I throw them a lot and they haven't broken yet.
Since Job Simulator is just literally representing your hand, we had a lot of problems with, because we're doing Vive Touch and PSVR, so having the vastly different controllers actually represent a hand that is supposed to feel like your hand was really weird. And it's funny because even multi-platform stuff aside, we have a solution for switching out controllers and stuff, but even on a single platform like the Vive, amongst our development team, we had people who would grip the controller differently, and people would say oh, it feels like my hand is rotated 5 degrees up, and it just feels like I'm walking around like this all the time. And just finding a happy medium of just one controller that felt like a hand was a difficult enough task in its own, I think.
We definitely play tested that on so many people to try to find out the right angle. Again, also because we're doing games about sports we know nothing about. So literally, we know nothing about any of the sports.
As far as controllers go, and we're focusing first and foremost on Vive because the Steam platform is more established and sort of their tech's a bit more evolved. But having said that, we try to abstract away our controller system as much as possible and our logic so that we can use different kind of controllers later on. But if someone's starting off and thinking that you can just take Steam VR and then just instantly make it work on Oculus, you're gonna have a lot of Steam specific stuff that you're gonna have to deal with. So abstracting away input systems and stuff like that is kind of important.
I think from the way we've been approaching it is the current implementation of controllers are not the way things are going to be static in the future. We still don't really know what the ideal tracked controllers are. So the fact that there's multiple ones on the market right now is a great opportunity for you as developers to learn how to really understand what actions, what gestures are really important in your game and see which controllers work well with that and get really good at iterating fast on these things, because this is one area that I'm really hopeful that we haven't locked down on, that the hardware gets better and better, and it's just going to accelerate faster as we go. So, next question.
Anton, I was really interested when you talked about removing colliders and focusing on kind of distances. It sounds a lot like how the Valve built the lab when they talked about hover distance. I was wondering if you could talk in a bit more detail about how you think about that and have implemented it.
Well, the first thing, I would sort of break down the things that I do because I try to use as much of the native physics system as possible. I always make sure that most of my physics layers collide with next to nothing. They basically collide with themselves, nothing else at all. So I'm always siloing them in ways where I need to use physics trigger and collision callbacks. I can predict, even in a crazy terminal, user has stacked 80 objects on each other case, what the performance impact is going to be. And then for subregions of objects, I've switched over, instead of having sub-triggers, basically having, I'd say, cascaded distance checks, where, say I have an object, like the mic, that has 3 or 4 zones on it that could be interactive. I first am periodically distance checking the hands to that object, and if they're within a given sort of threshold, I then distance check the subregions. So, and it's set up so that I can cascade that multiple times. At some point when I rebuild my API or re-engineer it, I'm probably going to go really hard in that direction. Because there's so many cases where people use triggers where far simpler, far cheaper math will do.
Hey again. So most of what I do is I do a 360 video lab, and I host a VR playground in New York, and I also host a meetup. So my question revolves around users, because I put a lot of first-time VR users through Vive and different VR experiences. So how much thought did you put into the initial experience into your game, like when a first-time user experiences your content? And second part, what was your favorite part about like a first-time user actually using your product?
Just to start off with a story, I guess, I had a really weird experience, well, it was a really cool experience of like, I'm from Winnipeg in Canada, which is kind of like a smaller city, not a huge like game dev industry. So we don't have too many like events and stuff, but there was this one event where we were doing Vive demos and just like getting the public to come try stuff. And this guy brought his 2 younger kids, and they were trying out Job Simulator and just like enjoying throwing stuff around and whatever. And it was probably like the weirdest experience I've ever had as a developer, where the dad came up to me and asked like, you worked on this game, right? Can I take a picture of you with my son?
Aww.
And I was like, wow, that's something cool.
I think like in general, so we're working on 3 games in parallel, and I really want them to be very sort of pick up and play. I can see with Selfie Tennis, since like it's a very jammy game, and we kind of just jammed through the entire development. So there are a lot of decisions that we made there that doesn't necessarily is so like pick up and play, whereas for the other games, we were working way more and making way more intuitive. Like the sort of ball and racket that's just on triggers, but like for instance, we have a double click, so the racket stays in your hand, and I think only 10% of our players know that. Like we have not been great at communicating that. So like other things like that, like for instance, archery, you literally just have the bow when you start, and then you spawn an arrow, and then that just works. That's very simple. That's all you need in that game, right? So in general, especially with first-time users, I've been exhibiting VR for almost 3.5 years now, so I kind of like went through the whole thing. I don't have a feeling like I don't necessarily need to exhibit more VR right now, because it gets very tiresome at one point. But it's very interesting to see what I call VR virgins, like how they pick up your game. And I can see it's a lot easier. Like I used to exhibit on a gamepad, right? Whereas a lot of people who had never played any video games, they would not know how to use a gamepad. Whereas again, like track controllers seems so much more simple and easy. And especially again with Move controllers or Vive controllers, you just pick them up. You have a trigger, everyone touches that, and they touch a touchpad. It's like, it's very intuitive. And I always like choose to focus the controls, like unless we're just messing around and doing jammy stuff, but on like trigger and touchpad. Like the grips are still a little bit unintuitive. Yeah, like it's unintuitive, and in Ski Jam right now we have the sticks on the grips, and for us, because of course we're developers, so for us it makes sense because you will hold them like that, but no one gets it, right? And that's a challenge that we now have to figure out. Do we stick with that decision? How do we explain it? And also, is it smart in any way, right?
I'm sort of, well, the exact opposite. I'm sort of the intransigent simulation nut. And so, like, H3 has a 40-minute YouTube tutorial.
Yeah,
and
I've watched through it, and I was
that gets
like,
you through the basics of the interactions. And so it's one of the reasons why it's not, you know, we rarely even demo it in public, because it's not 5-minute demoable. It's barely 20-minute demoable. Thankfully, we have sort of an icebreaker scene for it, which is grenade Skeeball. So it's like, pick those up, throw them up the ramp. You know how this works. We just pull the pin out first, and we use that to step them into, okay, here's something with 18 controls. But it's...
your grenade Skeeball. Oh, thank you.
What
What did the first user do in your grenade Skeeball?
I don't. One of the first ones, the best part of demoing it is the number of people who pull the pin out and go to throw it and flub their first throw and then panic because it's just going boom. It's like no. Great.
Just quickly, one thing that we do in Waggle is we have tooltips on the controller, no matter what, when you first start the game. So anyone turns on the game, there's tooltips, and they tell you how to turn it off. You just squeeze it, and they turn off. But it gives a preliminary, like, these are what these buttons do.
Yeah.
And they also always face you. And then just on a project that I worked on, the Leviathan project, I didn't have any design choices in that, but it was demoed at the Vision Summit, and it was a room where it was all tracked with Intel RealSense and a CV1. And you'd actually go, and you're standing in a lab with actual physical objects that you're moving and picking up. And that was the most natural thing, because people had their hands tracked, and they're reaching out and touching real-world objects and turning them, and it's all correlating in VR. So it wasn't Leap, it was RealSense, or Intel.
I think we just got the light that tells us we're out of time. So thank you very much for having us here, and thanks for the panelists.